This is section 4.6, completing the square. We're still trying to solve quadratic equations, okay? But in this section now, you're going to look at quadratic equations, and it's a possibility that they're not going to be factorable. And we haven't had that up to this point. Everything's been nice and easy, been factorable for us, and we've been able to do that. Okay, but our objective of this section, there's two of them. We want to solve quadratic equations that are not factorable by completing the square. And then we want to rewrite the equations by completing the square. Okay, so how is it that we complete the square of a trinomial so that it is factorable? Okay, so as we look at this, there's a couple of different things that we're going to talk about. Okay, what you're looking to do is you're looking to form a trinomial that will be factorable. Okay, so we're going to be able to find factors of C that add to B. Okay, or factors of A times C that will add to B. The nice thing about these and the ones that we're going to look at is that your A term is predominantly going to be 1. Okay, the only time we're going to look to complete the squares with those types of problems. If we don't have an A value of 1, then we're going to talk about that in the next section. Okay, so we want to create a C term that will make the trinomial factorable, right here, number 2. Okay, in order to do that, we're going to take the middle term, B, and divide it by 2 and then square it to make the trinomial factorable. So you're going to see this a lot, B divided by 2 squared. Okay, you'll need to then add it to the end of the trinomial. This is going to make your trinomial factorable. Okay, so you're going to have to be able to know what B is. You're going to have to be able to identify that. Okay, if you can't identify B, then yes, you're going to struggle a little bit with this section. Okay, you have to know what A, B, and C are. Those are going to be important parts as we move along in solving these. Okay, so let's take a look at this first part here. And what this says find the value of C by completing the square so that you have a factorable trinomial. You don't have to do any factoring on these. All you're going to have to do is figure out, okay, what number is it that we'll put here, that we'll make here, so that we can factor that trinomial. Okay, so the first thing here that we want to do as we look at this, the first thing that we want to do here is identify your B term. Okay, identify B. And then secondly, we're going to take B, divide it by 2, and then we're going to square it. And then we're going to replace C with it. Okay, so once we find that B over 2 and square it, then again, we're going to replace the C with that. So let's take a look here at number 1 as we're looking at this here. And first thing we need to do is we need to identify B. Well, as you look at this, you see that B is 6. Okay? B is 6. So we're going to take the 6, divide it by 2, and square it. Okay? So 6 divided by 2 is 3, and 3 squared is 9. So that's going to become your new C. So you're going to rewrite this trinomial as x squared plus 6x plus 9. Okay, and you'll notice, what are the factors of 9 that add to 6? Can we find that? Well, yes, there'd be 3 and 3. And then we'll be able to form a trinomial now that's factorable. Okay, let's take a look here at number 2 then. On number 2, we identify B to be 4. So I'm going to take 4, divide it by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. So that's going to be C. And then if I replace the C, I have x squared plus 4x plus 4. And what are the factors of 4 that add to 4? That'd be 2 and 2. Okay, now let's take a look at example number 3 here. Now, this time, B is a little bit trickier because B happens to be a negative 10. So we're going to take negative 10 and divide that by 2 and square it. Negative 10 divided by 2 is negative 5, and if I square negative 5, That's going to be positive 25. That's going to be C. So your new trinomial would be x squared minus 10x plus 25. And if you were trying to factor that, you'd find factors of 25 that add to negative 10, which in this case would be negative 5 and negative 5. Okay? So, example number 4. Again, B is negative 14.
TJ.
Okay, so B is negative 14, so I'm going to take negative 14, divide it by 2, and square it. Negative 14 divided by 2 is negative 7. When you square that, you get positive 49. That's going to be C. So now if I replace that C, I've got x squared minus 14x and plus 49. And if I find factors of 49 that add to 14, it's negative 7 and negative 7. So now I've created a trinomial that will be factorable. Okay? Then that's the luxury of completing the square for you. It will create a trinomial that you can use that is factorable. Okay? All right, let's take a look now at how are we going to solve these equations by completing the square. Okay, solving these equations by completing the square. Okay, first thing we want to do is we want to rewrite the equation so that x squared plus bx is on one side of the equation and c is moved to the other side. Okay, so I want it to look like x squared plus some number times x is going to be equal to the c moved over. Okay, so we're going to move the c term over. Then, okay, and the reason that we've recognized this is because, again, the trinomial is not factorable. And I'll show you when we first start some of these examples that first part, I can't factor that trinomial. So I want to make it so that I can. In order to do that, we're going to add a b over 2 squared to each side of the equation. And you'll see in capital letters there it says, you must add to both sides to make sure you keep the equation balanced. Okay, so whatever you add to the left side of an equation, you have to add it to the right so that you keep that equation balanced. Otherwise, you're going to completely change the problem. Okay, now, once we get done with that, we're going to factor the trinomial. And then once you've factored the trinomial, you can take the square root of both sides to solve the equation for x. And you're going to see what I'm going to do to make this problem a little bit easier. Okay? All right, let's take a look at the first example. Okay. Example number 1. It says x squared plus 6x minus 3 equals 0. So the trinomial is set equal to 0. If I were to try and factor this, can I find factors of negative 3 that add to positive 6? That's not possible because the only factors of 3 are 3 and 1. And so negative 3 and negative 1 will never be positive 6. So technically this trinomial is not factorable, kind of like the one we talked about at the beginning of class this morning. Okay? So I've recognized this trinomial is not factorable. I've got to get rid of c. So I'm moving it over. And I'm going to have x squared plus 6x. And then I'm going to leave a little gap. And it's going to equal 3. Okay, and I'm going to leave a little gap because what I'm going to do is I'm going to add a new number in here. Okay, so that I can make a trinomial that's factorable. So we identify what b is. Do exactly what we just did before. b is 6. So I need to take 6 divided by 2 and square it. Well, 6 divided by 2 is 3. 3 squared is 9. Okay, so the number that I'm going to put in here, I'm going to add a 9 there on the left side of the equation. Well, if I add a 9 on the left side, to keep it balanced, I have to add a 9 on the right. Okay, so I've got now, I have x squared plus 6x plus 9 equals 12. Okay, so as I look at this, what are the factors? Now I have a trinomial here that's factorable. So what are the factors of 9 that add to 6? So the factors of 9 that add to 6 are 3 and 3. So now I'm going to replace the middle term. X squared plus 3x plus 9 is going to equal 12. Parentheses around the first two and the last two. This take out an x, I'm left with an x plus 3. Take out a 3, I'm left with an x plus 3. So I have an x plus 3 in common, an x plus 3 left over, and it's going to equal 12. Okay? Now, as you'll notice, you see two terms that are exactly the same here. These two guys are exactly the same, the x plus 3 and the x plus 3. And I ask, if I have x times x, that's the same thing as saying x squared. So if I had x plus 3 times x plus 3, that'd be the same thing as saying x plus 3 to the second power. So I'm going to replace this x plus 3 with x plus 3 squared equals 12. Okay? Now, how do you get rid of a square term in an equation? Well, if you remember back to when we were solving by square roots, if I take the square root of a square, they cancel. If I take the square root of a square, they cancel each other. So if I take the square root of both sides here, the square root here, the square root and the square will cancel. There's nothing left, so it's just an x plus 3 equals, remember when I take the square root of an equation, I always have two answers, positive and negative, square root of 12. Okay? Now, before I go any further, I need to check and see, is this square root, can I break it down? Is there a perfect square that goes into 12? Well, absolutely there is. There is 4 and 3. Square root of 4 is 2. Square root of 3. So I'm going to change the square root of 12 to x plus 3 equals positive and negative 2 square root 3. Okay? Now that I've broken down the square root, how do I get x by itself? I'm going to subtract 3. So if I subtract 3, I'm going to subtract 3 here, subtract 3 here, and these are not like terms. Okay? The negative 3 and the positive 2 square root of 3, those are not like terms, so x is going to equal negative 3 plus or minus 2 times the square root of 3. And now you're done. You solve for x, and again, you still have two answers. You would have negative 3 plus 2 times the square root of 3, and negative 3 minus 2 times the square root of 3. Okay? So you can notice some of these problems can get kind of, they can get kind of long. There's a lot of work to them. Okay? A lot of work to them. Let's take a look at next example. Example number 2. Okay? All right. I need to know, are there factors of 7 that add to negative 12? And no, there are not. So I'm going to get rid of this 7. Okay? So now I have x squared minus 12x, and it's going to equal negative 7. Okay? And again, I want to keep that gap in there. So now my b is negative 12. Okay? So I want to take negative 12, divide it by 2, and square it. Negative 12 divided by 2 is negative 6. Squared is positive 36. So, I'm going to add 36 on the left. And again, if I do it on the left, I have to do it on the right as well. Okay? And so now I've ended up with x squared minus 12x plus 36 equals negative 7 and 36 is positive 29. Okay, so now I'm looking for factors of 36 that add to negative 12, and that's negative 6 and negative 6. So let's replace here. Okay, first two and last two. Again, this shouldn't be second nature to you right now. Take out an x, I've got an x minus 6. Take out a negative 6, and I've got an x minus 6. We have an x minus 6 left over. X minus 6 in common. It's going to equal 29. Again, I can replace these two terms, x minus 6 and x minus 6, to x minus 6 squared, because there's two of them. And now I'm going to take the square root of both sides to solve it. And the square root cancel, so I'm left with x minus 6. and it's going to equal the positive and negative square root of 29. Now, are there any perfect squares that go into 29? Well, no, there's not, because 29 is a special kind of number. 29 is a prime number, which means there's nothing that will go into it except for 1 in itself. Okay, so now I just need to finish this thing. If I add 6 to both sides, x is going to equal 6 plus or minus the square root of 29. And you're done. Okay, so we look at example number 2 there. Let's take a look at example number 3. Now, if you remember, we always want, on example number 3, we want x squared and x to be on one side. We want the number to be on the other side. Okay, so as you look at this guy, contemplate what you got to figure out and move. You'll notice c is already on the right side, but we have an x there. We want to get the x out of there. So now we have x squared minus 4x, and it's going to equal negative 1. Okay? So, as I look at this, I complete the square here. B is negative 4. If I take negative 4 divided by 2 and square it, that's negative 2 squared, which is 4. So I'm going to add a 4 to the left. Add it to the left, got to add it to the right. So, this is now x squared minus 4x plus 4 is equal to 3. Negative 1 plus 4 is 3. Factors of 4 that add to negative 4 are negative 2 and negative 2. First 2 and last 2, take out an x, left with an x minus 2. Take out a negative 2, left with an x minus 2. You notice they have an x minus 2 in common, x minus 2 left over. Okay, now, we've done 3 problems now, and I want you to see what kind of pattern we have here. Okay? You'll notice on the pattern, you'll notice that each one of these binomials, every time that you've done this so far, these guys have always been the same, and that's going to be true in every time you complete the square. So it's always going to be something plus or minus something quantity squared, like this. So in this case, we have x minus 2 squared. Okay, so now we're going to square root this guy and this guy. Square root and square cancel, so I'm left with x minus 2 equals, again, positive and negative square root of 3. Are there any perfect squares that go into 3? No, because it's a prime number. And if I add 2 to both sides, x equals 2 plus or minus the square root of 3. And again, so if I wanted to write this as 2 answers, I know some of you are probably wondering, well, that's not 2 answers. Yeah, it is. This is 2 plus the square root of 3, and x equals 2 minus the square root of 3. Again, there's 2 answers there. Okay? All right, example number 3. Completed with that guy. Now let's take a look at the next example here. Let's take a look here at example number 4. Now the one nice thing about this is I screwed up on example number 5, so we're just going to cross example number 5 out. Okay, you don't need to worry about example number 5. Okay, we'll go through some more examples in class here. Example number 4. All right, so you'll notice we have 2x squared plus 2x minus 5 equals an x squared. Okay, and again, we always want x squared and x to be on the same side and the number to be away from it. So I'm going to subtract this x squared. And I've got an x squared, because 2 minus 1 is 1, x squared plus 2x minus 5 equals 0. Now, the question is, can we find factors of negative 5 that add to 2? Well, the only factors are negative 5 and positive 1, or 5 and negative 1. Well, you'll never make 2 with that. So this guy isn't factorable. So I'm going to get rid of that negative 5. So x squared plus 2x, and I'm going to add 5 to each side to get it equal to 5. Okay? So in this case, b is 2. 2 divided by 2 squared. 2 divided by 2 is 1. Squared is 1. So I'm going to add a 1 here. If I add a 1 to the left side, if I add a 1 to the left side, I have to do it on the right. Okay, so now I have x squared plus 2x plus 1 is going to equal 6. Okay, so I need factors of 1 that add to 2. Well, that's 1 and 1. X squared plus 1x plus 1x plus 1 equals 6. First 2 and last 2. Take out an x here, left with an x plus 1. Take out a 1 here and take out an x plus 1. They both have an x plus 1 in common. They have an x plus 1 left over, equal to 6. Again, I can rewrite these two as 1 as an x plus 1 squared equals 6. Square root both sides. So now, again, square and the square root cancel, so x plus 1 is positive and negative square root of 6. There's no perfect squares that go into 6, so I can't break that guy down, so I subtract 1 from each side. And x is going to equal negative 1 plus or minus the square root of 6. Okay? So now, we went through 4 examples there. Okay? We went through examples on how to actually complete this square to make a trinomial factorable. So now we actually have an opportunity to take one that's not factorable and make it factorable so we can use that process. Okay? So when we get back to class tomorrow, we're going to go through a bunch of examples here in class and work together on trying to get this, because this is a little bit tougher concept, and it's going to take a little while, but you got to be patient with it. You'll get it. Okay? That concludes section 4.6, completing the square.